Hi, my name is Jerry Blake. I'm here at the Applied Micro booth representing Lauterbach. So I'm a sales engineer out of the Portland, Oregon office, and just wanted to tell you a little bit about Lauterbach and the products that we offer. So we've been in the business for about 30 years, so we have long-term experience in the debugger and emulator market. So what we're displaying here is one of our products supporting the Gemini chip. We've got a Gemini target up here. We're going to be going through some of the steps and what the debugger can offer you as we get along with the demo. So before the demo, a little bit about the company. So Lauterbach, been in the business a long time. We support a lot of different CPUs. We have a long-running relationship with Applied Micro, going back to the PowerPC 440 line as well. And we also now, some of the latest chips here, we also support the 82181 family, or 82180X family, you might refer to. High-speed serial trace for the Gemini. This is another item that we've added support recently here. This is enabling access to the trace information using the high-speed serial trace support that Gemini offers. The idea here is it's going to offer a compressed trace port that's going to allow us to grab trace, but minimum pin count on the CPU. So minimum pin count, minimum connector size, minimum traces, getting the trace information out of the chip. So what we have here is we've got the Trace32 debugger front end from Lauterbach. This is the primary software interface for all of our products, and you'll also notice that all of our products carry the Trace32 name. So if you see that around, that's kind of the common name that we use for all of our product lines. The Trace32 debugger over here, or we also call it the ICD or in-circuit debugger. This one here is set up to support the Gemini. With it, I've got a JTAG interface that's going to be used for us to control the chip over the standard JTAG port that Gemini offers. We then also have an extension onto this configuration, allowing the capture of the trace information or the historical cycle information that's coming across this high-speed serial trace interface. So this is a little bit in its premature state. This is done, it's finished, it's working. This actually won't be quite as delicate when the final product is shipped to the customer. But it is a working example here. This is a preprocessor for the HSTP interface. And what its function is to take the compressed high-speed serial trace information, decompress that into a parallel or a more standard interface for Lauterbach, so that we can have CPU-independent components on the back end here, and we've got CPU or family-dependent components at the end of the cable, or also the debug cable. So the debug cable could also include licenses to support more than just the Gemini. You could also add support for other CPUs, such as the 440, such as the 82180X family as well. Okay, so we're going to go through a couple of things just to show the level of support that you get with this debugger. So we've got a debugger front end connected up here. We are talking to this live target configuration. On the upper left-hand corner here, this will be your primary interface to control the chip. So this is where you're going to have control of the single step, start emulation, break emulation, set breakpoints, and so forth. Program counter is located on that gray line. That's where we know where we're at. At the start of our code, I've actually just loaded some application, run a script, it's loaded up some symbolic information. We've got the symbol table listed over here. You've got quick searching in here, so if I want to go look for a particular function or a structure or variable, you can just start typing it and it'll go to that variable. If it happens to be a function, we can hit the enter key. It'll bring up a window indicating that function here. We could then go down and set a breakpoint somewhere down here if we want to set a breakpoint and stop execution. So we're going to cruise through a bunch of function calls. We're going to end up at this location, and it's going to stop execution. Okay, so let's go ahead and let her rip. Okay, so from this point, we now have hit a breakpoint. The CPU is stopped. We've got an indication of what's happening with the CPU down below. So one of the things you can gain access to is the history of what happened getting to that point. And that's the key of having the trace interface. that Applied Micro is supplied with the Gemini chip. So if we go take a peek at the raw data is going to give us a couple of things. It'll relate it back to the assembly code. It'll also associate that assembly code back to the source level code as well. So we're going to see a flow of the code of what transpired getting to our particular breakpoint where we stopped executing at this return. Okay, so you've got full access, very quick access to all the information that Lauterbach presents in the debugger. You can also scope or zoom out your view. So if you want to look at just a higher level view of your code, you can get rid of the read and write cycle, and you can go on up to just the high level code flow. And this can also, this being the code flow, not necessarily the way the code moves. If you were to look at the actual source file. So if you want, you can also enable a tracking window that'll track back between the different windows. So if I go to trace window, I want to see what this looks like in my real C code. Go there and it'll track back and show you the actual source code at that location. Now, this is kind of the basics behind the trace collection. You've got the history of what happened getting to that point. So you've got the dynamics now, not only the static view like you have in a standard JTAG debugger, or if you just had a JTAG interface, but you now have the dynamics of time incorporated in this. So with this dynamics of time, you can also look at a chart. So the chart can give you a real good feel of the execution of your code over a timeline, what functions are executed, and this can also operate not only just on a basic function level, but if you have an RTOS, then you can also have it be RTOS aware, and this could be representing threads or processes or kernel resources that are being executed. So different ways to look at this. Not to go into too much detail, I know it's supposed to just be a quick clip here to show you what's available. Another thing, in the performance format, you have the availability to look at some numerical statistical information. So the statistical information, once again, these are the names of my functions for this example. We've got main up at the top, and across here you've got the total amount of times in each one of those functions. You've got it broken up into the minimum, maximum, and average, and also we indicate how many times we've seen that particular function called. So for example, if we were looking at this function 1, we've seen it called 10 times within the trace capture that we've captured over here. Which, by the way, this comes in a size of either a 1, 2, or a 4 gigabyte size. So that can record quite a lengthy amount of history prior to your breakpoint. And you can also control what goes into the trace too. You don't have to just control, capture the information up to a breakpoint. You can simply capture the information up to a point where you turn off the trace and let the CPU keep cruising. So there are other aspects to this as well, just to give you a quick overview. These are some of the nice things about these. Other things that Lauterbach offers is a quick interface to your peripherals. So a chip like this, it's got a lot of peripheral registers or special registers, and this is going to give you an access to these special registers and break out all of the different fields that make up those registers. So if we were to take a look at the chip initialization registers for the Gemini, you'll see the entire register on the left, and you'll see all the fields that make up each of those registers to the right of it. And you can also gain access to various optional settings by right-clicking, and it'll indicate what are the possible settings for that particular field. You could go and change the settings, and that'll reflect back into the actual higher register over there. So we try to bring things to the user of the debugger in a friendly fashion. You do have breakpointing capabilities like you would expect in any debugger. If you want to do complex breakpoints, you can see I have the software breakpoint that I originally set here earlier. If you want to make this a little bit more complicated, there's also an advanced section on the breakpoints, and you can qualify your breakpoint with whatever logical condition that you want to. So if you want to look for the value of a maybe a non-static or a stack variable or a register variable, you can make a conditional check in there as an additional check to the breakpoint that you're setting. So this is about, I guess, probably a good intro to what we're showing here. We welcome anybody to give us a call, and we go through a full demonstration. Probably set aside an hour, hour and a half to get through all of the different features, because it's literally packed with features behind the scenes. So please feel free to contact Lauterbach. Website, you have a sales tab. You can find me there, Jerry Flake.